Math 2, Section 3.5, Part 2. So we are going to talk about corollary. So read it in your groups. Talk about what it reminds you of. There's 2 theorems there. Okay, so the first theorem right here, it says that if it is an equilateral triangle, then it's also equal angular. So if the sides are equal, then all the angles are also going to be equal. Okay, then you go down to this next one, and they say what? Yeah, or the converse, okay? And that is if they have equal angles, then the sides will also be equal. Does this kind of remind you of yesterday too, when we were talking about the isosceles? Okay, where if you have the same sides, you have the same angles. If you have the same angles, you have the same sides. Right, guys? Okay, good. Okay, so we're going to move on to page 160. Okay, so it says, suppose the triangles in problem 3 are isosceles triangles, where angle ADE, and so ADE is right here, and DEC, which is right here, and ECB, which is right here, are vertex angles. If the vertex angles each have a measure of 58, so we're saying that these measures are 58. What are measure angles A, and then also, so we're looking for the measure of angle A, and then also angle BCD. So if you notice, BCD is actually like a vertex angle and one of the other angles together. Yes. Okay, so brainstorm in your groups what you can do to solve this one. So if we just look at this first angle right here, trying to solve for angle A, and we know that the vertex angle, that top angle, is 58, and we know that the other 2 angles are equal, or x, can you solve it? Okay, let's see what you can do. Talk about it in your groups. Talk about how you're solving it. See if you guys agree. Okay, if you get the answer, raise your hand. I'm going to come and check it. Okay, and see if you can get the next one after that. Perfect. Okay, so now try to find that big angle. Okay. Yep. Perfect. Awesome. Now, find the next one. Yep. So 58, it even told you up there, it's measure angle ADE. Okay, do I have a volunteer that wants to go up and do the problem on the board? I can check your answers.
Yeah, I just like didn't do that.
One way to find it is plus x plus x equals 180. Okay. And that makes sense to you. Wait a second. So we just see the subtraction a. 2x divided by 2 Okay, so nobody wants to do it. There are multiple ways of setting up this problem. One way, if we were to write an algebraic expression, would be if we label each of these angles, A and E right there, they're both going to be the same values. We know that because these two sides are equal. Okay? And so I'd write this as x plus 58 equals 180, because I know that A was 58 and I know these two have to be equal. Okay? I would subtract 58 to both sides. Okay? When I do that, and x plus x is how much? 2x, okay, equals, and when I subtract, I have to borrow, and I get 122. And then in order to solve for x, I divide by 2 to both sides, and you get x equals 61. Okay, once you know that each of these angles are 61, we know that this part right here, by angle C, that's 61, and we know that this vertex part right here with C is 58. And so in order to find out what that big angle is, the D, let's say, sorry, where am I looking at? BCD, you have to add the 61 and the 58 together. Okay, and so 61 plus 58, and you get 119. And that was for measure angle BCD. Okay, do we have any questions there? Does it make sense? How many of you got it right? On your own? Ish. Good. Okay. Problem number 7, okay? The equal angular, if I can say that, triangle and the isosceles triangle shown here share a common side. What is the measure of angle ABC? So they're wanting this whole angle right here. So let's write in the information that we know. So if A is 66, what other angles do I know are 66? C is not 66. D. Okay, now you have to look at these like equal, like separate triangles. Okay, so this is your isosceles. I know that's 66 and 66. So can I find the measure of angle just B? Okay, how will I find the measure of angle B? Okay, so good. And I could write an equation, x plus 66 equals 180. Okay, so let's go ahead and solve there. What is 66 plus 66? Very good. Equals 180. And what would I do to get x by itself? Very good. And I find that x equals what? So we borrow, and 48 is correct. Okay, so that means right here, that portion is a 48-degree angle. Now, these slash marks, it's a separate triangle, okay? We do not know what these angles are, but we know that all the angles are what? Equal. How many angles are there? 3. So we would write this as 3x equals 180, because x plus x plus x equals 3x, right? Each angle would be the same. And then what would I do in order to get x by itself? Good. Divide by 3 to both sides. And so we get x equals 60. So that means this part over here is 60. And each of these would be 60 here. Does that make sense? How you kind of have to look at them as different triangles? Okay. Now what will I do? So in order to find that angle, what am I going to do, Robert? Very good. We're going to add 60 plus 48. And when we do that, we get 108. So that is my answer for measure angle ABC. Okay. Yes, Joseph. Where did I get which one? The 66s? They told us in the problem. Right there. So since this one, they told us here it was 66. And with this triangle, do you see how it has the 2 slash marks? So that means that the 2 bottom angles are 66. So since that's 66, this one has to be, and then we just have to find the missing one. Okay? All right, any other questions there? Okay.